Hello and welcome to this repair tutorial, and today we're going to look at a Rotel, and the model number is RC-03 and this is a pre-amplifier. In terms of general specifications, input sensitivity is 1.2 millivolts with an input impedance of 68 kiloohms. For your other inputs, which we refer to as your line, it is 150 millivolts with 24 kiloohm impedance. Output level stroke impedance is 1 volt at 100 ohms. And then frequency response is 20 Hz to 20 kHz, and total harmonic distortion is 20 Hz to 20 kHz at 0.004%. Dimensions 435 wide by 72 high by 328 millimeters deep, and the weight is 4.3 kilograms. This preamplifier is also provided with a remote control. Now, what was the issue with this amplifier when it came into the workshop? Well, it had really two main issues. The first one is not uncommon, particularly of amplifiers of this age, and this is where you have input skipping. So the user can be listening to music, and then intermittently what you'll find is that the input selection will just jump. It just skips different inputs, and then you'll see the LED change. And then the other one, which we'll get into in a moment, is where you have this contamination with this brown conductive glue. But before we get into both of those faults and what we did then to correct them, the first thing that we're going to do is just take an aerial shot here and just highlight with regard to what we're seeing. At the rear you can see the input RCA sockets, and just to the left, more little compact relay. That energizes then to provide the output to whatever is being connected to the preamplifier. And then where you see the large integrated circuit, this is the dedicated input selection IC. So it's not using mechanical switching, and you're not seeing individual relays to select each one of the inputs. And then the board, which is mounted vertically and is actually surface mounted components, this is your moving magnet type cartridge stroke equalizer stroke preamplifier. And then on this shot, what we're showing you is the microcontroller. You'll also just note as well, just to one of the smoothing capacitors, there's also some of this glue, but you'll see that in a little while as we go through. And then here, when we take an aerial shot again, this is really showing you the complete layout of this preamplifier. So towards the rear on the left hand side, you can see this toroidal transformer, and it's not large. Remember, this is only a preamplifier, it's not a power amplifier. And then you can see the individual fuses. There's also a relay as well, but again we'll come back to that. And also the circuit board, which is mounted at the rear. As you move towards the front of the amplifier, you can see the motorized volume control. There's also a mechanical selection switch, which is just selecting between tape and source. And then, as we saw a moment ago, you can also see just to the right the microcontroller. You can also make out as well this brown glue, but if we go into a little bit more detail here, you can see the extent of this glue. So really, to go over this again, because probably most of the tutorials, if people regularly follow along, I've covered the repair of many different devices, and this is probably by far the most common issue. It is unfortunate for the owners of these amplifiers because you pay relatively high prices for audio equipment, and then the amplifier will fail after a period of time. And it's not because the components fail, it's this brown glue which has contaminated them, and then it also becomes corrosive and conductive. So what we do is, like all repairs, we have to just take a systematic approach. So here what we'll be doing is just desoldering each one of those components, and then we just clean away the brown glue. So here you can see that this brown glue is making contact with multiple components. And the origin of this glue is such that when it's first applied during manufacture, they put it around the electrolytic capacitors. And really it's down to the individual person who is building that amplifier. And this is why you see sometimes the glue will be extensive, and then other amplifiers you look in there and there's really a minimum amount of glue. But it is really a shame, the fact that it does cause these issues and lead to both expense for the user, and also the amplifier of course will fail. And then here what we're also pointing out is just to the rear of the amplifier, you can see just on the left hand side, these are the input protection fuses. And then you can also see as well some more of this brown glue. Just to the right where you have the relay, you can see that there is a metal tab. Now when you take the amplifier apart and you remove the bottom surface plate, that is one of the grounding connections. So It just ensures that when you reassemble the amplifier that screw is in place, but just make sure it's nice and tight. Okay, you don't want the case where maybe the bottom plate is not fully secure, because you can then get noise and then pick up as well. And the relay is used there for the trigger control. And really what the trigger control is, and that's that circuit board at the rear, is where if you wish you can connect an external signal source to a voltage source, and then you can have, for example, a master turn on turn off signal which will control all of the devices within your stack system. And then here, if we focus in a little bit more detail, this relay was replaced, and it was replaced because of the age of the amplifier, and we didn't want any issues with oxidization or maybe intermittent switching. And these relays are not expensive. Specifications wise, they are 24 volt DC coil, and you have 2 contacts in here, and then the current rating is 5 amps. And then on this shot, what you can see is that we've removed all of the glue, and you can see that it's undergone an extensive clean. So really the issue associated with glue in the future will be no concern, and it just puts the longevity back into the repair of the amplifier. Now, when we talk about the input selection issue, you saw the case where it will just randomly switch between different inputs. The first thing that I'm showing you here is an extract from the service manual, just so you get more information with regard to how this looks in terms of operation. So what we're pointing to is the microcontroller containing no user-specific program code. It is the manufacturer, or the original equipment manufacturer, the OEM, who will write the program code, which in turn then during production the microcontroller will be loaded then with the firmware. And then to the right hand side, I'm just pointing out the input selection encoder and switch, and this is simply a rotary switch, but they also use it as an encoder. And what we mean by an encoder is that each time the operator or the user will make a change, the microcontroller will see that status change and read that as an input. And when it does that, what it will do is really 2 things. The first one is, and if you look above from the microcontroller, there is another integrated circuit, and that is an LED driver. And then in turn, the micro will also send a command signal off to that dedicated input selection IC. Now, the problem with this switch is that over time, intermittently, the micro will see a change of signal. Now, to get access to this switch, the first thing that you have to do is to remove the front bezel, and you can see here that this is the LED indication board, and it unplugs them from the amplifier board, and you can see that there's 2 fixing screws. So once you remove them, what you'll then find is that there is a locking nut on the switch, and then here what we show is the switch removed, and you have the cables which again connect to the amplifier board, and you just lift up the locking mechanisms on those clips, and then you can remove the multi-ribbon cables. Now, you could attempt maybe to spray some form of switch cleaner into there, but you're not really going to get the kind of longevity that you're looking to have here. You've got to remove this switch, and you've probably got about 24 solder connections that you need to desolder. But once you do that, you'll be able to then disassemble the switch. And then here what we show is that switch taken apart, and the switch wafer, as you can see, is heavily oxidized, and you can see it's like a brownish tint on there. That is the original lubricating grease. Now, when you do this work, just make sure that you're not going to use anything heavily abrasive to clean that up. So what I'm referring to here is don't go and get some sandpaper and then start to sand it. What you need to do is to use a high quality switch cleaner, which will dissolve that grease which is on the contacts, and then just simply take a fiberglass pencil and then just stroke it over those contacts. And then what you'll then see is what we see here. You'll see that these contacts now are very, very bright, and it's a simple case then of me just applying some high quality lubricating grease onto there and then reassembling the switch. And then once that is done and the switch is then put back in place, the operator will have no concerns with any aspect of intermittent switching. It will be completely reliable. Now, as with all amplifier repairs that are undertaken, we always scan the circuit board to ensure that there's no dry solder joints. Now, overall, Rotel is good. They don't really have a sparse amount of solder on there, and also the circuit board layout is very good. So it's not common that you're going to get sort of stress points, or maybe you're going to get components which are running excessively hot. and the circuit board quality maybe is not as good as what it could be. But still take the time, just scan around, and then any which look maybe grey or sort of off colour, by all means just resolder them, and then again that will just ensure that reliability. And then here what we're doing is we're just looking from the rear of the amplifier. What I'm just sort of pointing out there is that you can see the large electrolytic smoothing capacitors which are towards the centre, and then from the front you can also see the balance control. So this is just a conventional double gang potentiometer, but you do need to clean these switches and also the volume control. So we just use De-Oxit D5, spray into there and also into the tape and source switch. Just operate them multiple times and also clean the headphone socket, and you'll be rewarded with reliable operation. The other thing that was undertaken was really just to make an equivalent series resistance measurement on all of the electrolytic capacitors, just to make sure that they were in tolerance, and they were. These capacitors are Rubicon, and none of them had deteriorated, and all of them was well within specification. Because it's a preamplifier, these capacitors are not working as hard as what you would see maybe in a power supply for a power amplifier, which is working extremely hard. Here the electrolytics are relatively small, and as we said, it's not a bad board layout, so they're not sitting next to voltage regulators or power resistors, which would prematurely age them. So once that work was all done, then the only thing that remains is to place the amplifier onto test. And as with many of these Rotel amplifiers of this period, it is a real pleasure to work on them and then to restore them. And it just ensures, as I said many times throughout the tutorial, just this longevity. So you're very confident that you haven't just repaired the issue maybe with the random switching. You've taken care of the brown glue issue and then any dry solder joints, just making sure that everything that can be done is done. So that sort of brings us to the end of this repair tutorial, and if you have any questions or you need any guidance, assistance or help, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any support that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.